Alright, welcome back again to the Make It Happen TV super secret off-grid West Mississippi wink wink remote property. No, not really. We're out here in the city. Gas meters and air conditioning units and shit like that, the transformers and transmission lines, you know, all the stuff we hate. But I come out here, we're doing a little family thing, doing a little Christmas. So we're out here in the city, and we're visiting some family, and so I'm bored as shit with that, you know how that goes. So I say, make a little video. Well, I'm outside, I'm poking around, I find a storage room. Hey, what's going on? What's in this storage room? Not a lot. I think a hamster might have died in here, since there's a dead hamster in this room. No. Okay, so it's just a storage, just a little storage closet in an apartment. I would turn the light on, but there's no bulb. But I've seen this pipe, and this just looks to me like it's just some thin wall EMT conduit. I also look down and I see these hamster parts. So hey, look at this. Look at these hamster cage parts. And it got me thinking about differences in pipe sizes. And how much water or gas or anything could flow through different pipe sizes, depending on their size. So I'm going to do a little bit of drawing. I'm going to do a little bit of illustration to describe how the size of pipe changes counter to your what you might think instinctually. Its area equals pi times shit sucks, man. Okay, so our generous hosts have given us not only a room, but a pen and a piece of paper to illustrate this concept. So let's pretend, if we can get you in focus here, let's pretend we can focus. Let's pretend we have a 1/2 inch diameter trade size pipe. Okay, call that 1/2 inch. And we also have a 2-inch diameter trade size pipe. How many 1/2 inch pipes would it take to replace a 2-inch pipe? I think a lot of people would say, well, 2 inches divided by 1/2 inch equals 4. The inches, they cancel, right? It would take 4 1/2 inch pipes to replace a 2-inch pipe. Well, that's not true, because the flow through a pipe is not directly dependent on its diameter, the distance across the pipe. We're not talking about, we're talking about how many diameters the difference is. Well, yeah, you could fit 4 1/2 inch pipes across here. But look at this other space. We've got all this space. We've got all this other space to deal with. So when the question is how many does it take to replace, if I want to replace this 2-inch pipe with 1/2 inch pipe, what does it take? What does it depend on? Well, turns out it depends on the area of the pipe, the square inches. Don't give me a bunch of stuff about, you're better than me because you use the metric system or something. It doesn't matter what units you use. The physics holds true. It's 1/2 unit wide, 2 units wide. So inches, meters, miles, light years, whatever you call it, half a unit, 2 units. I'm going to use inches in this example. And if you can't follow along, I apologize. So what's the area of a circle? Well, the area of a circle is A equals pi times the radius squared. So what's the radius of this 1/2 inch diameter pipe? Well, that diameter is 1/2 inch, so the radius must be 1/4 inch. And likewise, the diameter of this pipe is 2 inches, so the radius must be 1 inch. Okay? And we plug these numbers in. Let's go ahead and illustrate that. Here's a small pipe. A equals pi, which is 3.14. It's a 3, not a 5. It looks like a 5. 3.14 times the radius squared The radius is 1/4 of an inch, so 0.25 squared equals pi times, 25 squared is 625, and this is an order of magnitude less, or would be if it was a decimal, so 0.0625 equals 0.19625 square inches. Okay? Okay. Pi are not square. Pi are round. Silly human. Now we get a 2-inch pipe. A equals 3.14 pi times the radius squared, squared equals pi times 1, because 1 squared is just 1, and equals 3.14, focus, square inches. Which is an interesting thing here. A circle with a diameter of 2 will have an area of pi square units. Interesting. So 2 units wide, pi square units in area. But at any rate, so we determined that the radius has changed by 4. The diameter has changed by 4. The radius changed by 4. So the diameter increased by 4 times. So the radius also increased by 4 times. We went from 1/4 inch to 1 inch. So change of magnitude by 4. Okay, so 4 times the diameter, or 4 times the radius. So what happened with the area? As this changed by 4, how did the area change? Let's take a look. Well, 3.14 square inches divided by 0.19625 square inches. Well, the inches cancel. All right, the square inches cancel. And we get an answer of exactly 16. 16. What does that mean? What are we asking here? The question is, I have a 2-inch pipe. I've got a really good deal. Got a really good deal on some 1/2-inch pipe. And I got to replace this 2-inch pipe. How many 1/2-inch pipes will it take to replace it? 16. Not 4, but 16. It'll take 16. All other forces being equal, the pressure being the same, the coefficient of friction being the same, everything is the same. Except now I want to replace this pipe with an equivalent number of these pipes. What is that equivalent number? That number is 16. You're going to need 16 1/2-inch pipes to blah, 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 to replace a 2-inch pipe. Now that's amazing, but it's not surprising. Why 16? Why did we increase the diameter by 4 times, but we increased the area by 16 times? Well, that's because the area is dependent on the radius squared. See, the radius squared, that's the important term. That's the important factor. So the radius changed by 4 times. So that means the change squared as well. So the radius squared with a change in radius also squared. What was the change in radius? The change in radius was 4. What's 4 squared? Well, that's 16. So it's not a mystery. We didn't have to do all this to figure out that a 2-inch pipe was 16 times bigger than a 1/2-inch pipe. All we had to do was check out the change in the magnitude and square it. The magnitude went up by 4. If our change of magnitude of 4 times, 4 squared is 16. That's our answer. That is it. It's almost mind-blowing. I guess if your mind is blown by simple geometrical truths. It'll blow your mind. This also applies. I could go on. I could make videos. I mean, this is important not just for flow through a pipe. The cross-sectional area, and what I mean by cross-sectional area is, you have a pipe, right? You have a pipe here. You cut through this pipe, and versus this dimension, this circle represents its cross-sectional area because we've cut across the pipe. Okay, so this concept of cross-sectional area isn't just important with pipes. Electrical conductors, wires, the ampacity, how much current a wire can carry, is directly dependent on its cross-sectional area. Friction, splitting a log, let's say, is directly dependent on how much cross-sectional area your axe head has to push through. And as the area changes, as the diameter or one dimension or another, even rectangles, it doesn't have to be a circle, it changes by the square because area is a square. So, for example, let's say you have a 5x7 photograph. 5 inches by 7 inches, right? 5x7 photograph. And you say, well, I want a frame that'll fit that. I want twice the size. So what's twice the size of a 5x7 photograph? Well, let's see, if we doubled both dimensions, we'd get a 10 by 7, or I'm sorry, a 10 by 14 frame. But let's check this out. Look how many we can fit in there. Look what happens. You didn't double the size. You can fit 1, 2, 3, 4 of these photographs in this frame. Why? Because the area of the rectangle, 5 by 7, right? 10 by 14, well, this doubled, so 10 equals 5 times 2, and this doubled because 14 equals 7 times 2. Well, this times 2, we changed it by 2, right? We changed the size of each dimension by 2. Therefore, because we're multiplying these two together, 5 times 7, these two 2's multiply together. They become squared. 2 squared equals 4. So we have 4 times the area. If we just change these sizes by 2, 2 times 5, 2 times 7, we're going to get a 4 times increase in the area. This concept is so little understood in the trades or in common language, colloquial peoples, that it's just as easy to make that mistake. Oh, sure, a 2-inch pipe is 4 times bigger than a 1/2-inch pipe. No. A 2-inch pipe is 16 times bigger than a 1/2-inch pipe. A 10 by 14 frame is 4 times bigger than a 5 by 7. Get this concept. Understand how area determines many properties of physical systems, and so much light. It's like a light bulb comes on. You suddenly understand things that you didn't understand before, just by understanding that things change by the square of the change of the magnitude. So let that soak in. As always, comment down below. Give me a big thumbs up if you understood anything, if you learned something new. Click the subscribe button. Follow along. We're going to go through this stuff all the time. Rambling math and physics and just whatever comes to mind. Stay frosty, everybody. See you on the flip-flop.